All right, today we're diving into a concept that might just redefine AI as we know it. It's called continual learning. And look, this isn't just about making AI a little bit smarter. It's about giving it something it's been missing, a real memory. Let's get into it.
It's pretty incredible when you think about it. Modern AI has this vast, almost unbelievable amount of knowledge. It can spit out code, it can explain quantum physics, it can write your emails for you in seconds, all by pulling from this giant library of information it was trained on.
But here's the big question, the one that really matters. After all those chats, all the times you've corrected it, all the new things you've told it, does your AI assistant actually learn from you? Does it get any smarter from one day to the next because of its interactions with you? Well, the answer is not really.
And that brings us to what we're calling the AI learning gap. See, while we humans are constantly learning and evolving, most AI is, well, it's basically frozen in time. Let's dig into why that is.
Think about your own brain. Every single day, you're learning something. It could be a new fact, a better way to make coffee, or a mistake you're definitely not going to make again. Our intelligence is dynamic. It's always being updated and refined by what we experience. That's kind of the whole point of being human, right? AI agents, though, for the most part, they're static. They get trained on this massive pile of data, and then that's it. Their knowledge is locked in at that moment. So even though they're incredibly powerful, they don't really get better through their individual interactions with us.
So why the gap? Well, for decades, the way we tried to make AI learn was, to put it mildly, flawed. Let's talk about the old way of doing things, and what I like to call the trouble with weights.
So the old school thinking went like this. For an AI to learn something new, you have to go in and tweak its core programming. In a neural network, that core programming is made up of millions of little knobs and dials called weights. So the idea was to constantly adjust those weights. They call this learning in weight space.
But this whole approach slammed right into a massive roadblock with a, frankly, brilliant name: catastrophic forgetting. It turns out, when you tweak the weights to teach the AI a new trick, you run the very real risk of accidentally wiping out something it already knew. And this is the perfect analogy for it. Just imagine you spend months, maybe even years, getting fluent in Spanish. You're amazing at it. But then you wake up one morning and realize you've completely forgotten how to speak English. That's catastrophic forgetting. And that's why this whole method has been so darn difficult to get working in the real world.
And the problems didn't stop there. This weight-based approach is just a total headache. You have to carefully prepare all this data for every little update. It's way too slow to do for every new fact. It opens up all sorts of privacy risks with user data. And if you mess up, there's no easy undo button. No way.
Okay, so this is where the story gets really interesting. Faced with all these roadblocks, researchers had a huge aha moment that just completely changed the game. It reframed the whole problem and led to a brand new idea: learning in token space.
The question they started asking was so simple, but it was also profound. If messing with the AI's core programming, the weights, is this hard and this risky, what else can we change?
And the breakthrough, the key insight, was realizing that an AI agent is more than just its pre-trained knowledge. It isn't just its weights.
It's the weights plus its context. And that context is everything. The system prompt that tells it how to behave, any documents it's looking at, and, this is the crucial part, the history of your conversation. This super simple equation, it changes absolutely everything.
So, this is the big idea behind learning in token space. Instead of trying to change those complex, unreadable weights, you just update the simple, human-readable text that makes up the agent's context. The learning happens in the text, the tokens, not in the guts of the model itself.
So, how does this new way of thinking really stack up against the old one? Let's do a quick side-by-side comparison, because the advantages of learning in token space are just huge.
Okay, let's break this down. With the old weights method, everything is a black box. It's opaque, you can't read it. But in token space, the memory is just human-readable text. You can see exactly what it's learned. And that memory is portable. You can take it from an old AI model to a new one. Best of all, the control. If you want the AI to forget something, you just delete the text. You can have versions, you can roll things back. It is a complete game changer.
So you see, this new approach isn't just about fixing an old problem. It actually gives us a brand new roadmap for the future.
We're finally talking about building machines that can truly learn and evolve with us.
And one of the most exciting ideas to come out of this is sleep time compute. I love this. It's exactly what it sounds like. You know how our brains process the day, consolidate memories, and make new connections while we're sleeping? The idea is an AI agent could use its downtime to do the exact same thing, to process its experiences, refine what it's learned, and actually get smarter between tasks.
So the path forward looks something like this. First, agents will use that sleep time to organize their memories. Then they'll actually become self-aware of their own memory, learning how to manage their own context. And finally, we'll probably see a hybrid approach, where the most important memories from the token space get distilled back into the weights to make things more efficient.
And all of this leads to a really powerful quote that just perfectly sums up this whole shift in thinking. The weights are temporary. The learned context is what persists. AI models are going to come and go, right? Each one will be more powerful than the last. But the memory, the unique shared experience an agent builds with you, that can be permanent.
And that leaves us with one last kind of mind-bending question to chew on. In a world where an AI's experiences can just be transferred from one model to the next, what happens when an AI's memory outlives its original mind? Pretty wild stuff to think about. Thanks for joining me today.